All right, so we've got work solutions here for our multiple choice short answer questions. I'll just go relatively quickly. These aren't the only way we can do things, and don't forget, we've also got access to calculators. The trick with the first one actually is that this transformation, okay, maps a function to the graph of y equals x squared. I must confess, when I first read it, I thought we were transforming y equals x squared, but we're not. We're transforming some function into y equals x squared. So this is the new function. So if I expand my transition matrix as I normally do, I'll get x dash is equal to x plus 5, y dash is equal to negative y. I've got the new function y dash equal to x dash squared, and I want to find the old one. So I can just substitute my y dash and x dash in. Y dash is equal to negative y, x dash was equal to x plus 5, and come up with my answer. Okay, so that's what the original function was, A. Same sort of thing, couple of ways. If we apply the transformations, x dash y dash translated 4 units vertically up means y plus 4. Reflected in the y-axis. So in the y-axis means it's about the y-axis, so the x-coordinate changes, so it's minus x. And so now if I put my x and y values in, I'll end up with negative 4, positive 1. Again, transformation matrix, x dashed is equal to, multiply, negative x plus 1, y dashed is equal to 2y minus 2. Rearrange to get x equals and y equals. So there's x equals, there's y equals, and I substitute that into my original equation to end up with my new equation. So swap for x, swap for y, multiply through terms. That's what I was looking for, to be honest, but as it turns out, that form of the equation was the one that they were offering us for C, and so there's our answer. Little short answer one here. Same process though. We've got y equals 1 on x has been transformed by this matrix. What's the new rule? So again, x dashed is equal to 2x plus 1, y dashed is equal to 4y minus 3. So don't forget that the rule that I've got is y equals 1 on x. So it's in terms of y and x, so I need to get y and x. So x is equal to x dash minus 1 on 2, y is equal to y dash plus 3 on 4. Substitute those x and y terms into my equation I've been given, y equals 1 on x, and I've got it here. So I flipped the 2 upside down to begin with to make it 2 over x minus 1, brought the 4 across to make it 8, because don't forget I'm multiplying by 4, and then subtracted 3 from the other side. All right, and so now there's my new rule, okay? But the question wanted us to identify what the A, B, and C values were. So that's the answer that we should be producing. All right, so 2 marks to there, that's your 3rd mark there. All right, the graph of the function y equals 2x squared is translated. Okay, that's fine. So again, there's 2 ways we can approach it. We can just consider what happens with the function law and function rule and apply it to the rule. You know that I prefer us to stick to my coordinate, my x dash, y dash, and just follow the same process all the way through, all right? So if I go 2 units to the left, I move to take away 2 from the x coordinate, dilate by a factor of half from the y, as my x coordinate gets affected as well. What happened there? And then if I move 1 unit down, I subtract 1 from the y value, all right? So I get my x dashed is equal to a half x minus 2, y dash is equal to y minus 1. Rearrange everything, multiply both sides by 2, then take the 2 across, then just take the 1 across. So I've got my y equals and x equals, substitute both of those into the equation, and I get this form of the equation here for B, which is the answer I'm after. Okay, so we've got a graph here. It's been let's have these transformations apply to it. So the negative out the front flips everything upside down. The 2 out the front increases all of the y values by 2, doesn't it? So that's what I've sketched here. I've flipped the graph upside down, so the intercepts didn't get affected at -2, 0, and 2. But I've flipped each of them upside down and increased the size of the turning point a little bit. And then the x plus 3 inside shifts everything 3 units to the left. Yeah, so my intercepts become instead -5, -3, -1. All right, and so the only one that sort of gets anywhere near that is, E and B. And obviously the difference with B is it hasn't been reflected. All right, so E is my answer there. Question 14, similar one to we've had earlier. The 0.35 are a reflection in the x-axis. So in the x-axis means the y value changes sign, so that becomes 3, -5. 2 units in the positive direction, which means I add 2 to x, gives me the 0.5, -5, which is D. Back to the question 10 labelled. All right, again, what are the series of transformations that are taking place here? So x dash y dash is equal to reflection in the x-axis, y value, -y. Divide by a third from the y-axis means my x value gets affected, a third of x. 3 units left means I'm subtracting 3 from the x value. All right, so there's my series of transformations. X dashed is equal to 1/3 x minus 3. Y dash is equal to -y. Again, let's just go through the same process and get x equals and y equals. So if I take the 3 across and then multiply both sides by 3 to get rid of the third, we get 3 times x dash plus 3 equals x, and y equals -y dash. So if I now substitute that information into the rule, and my rule is y equals f of x. So wherever I see y, I put -y dash, and wherever I see x, I put the 3x plus 9 if I expand the brackets. So I get y is equal to the negative of 3x plus 9, which is what we have for C. Which of the following could be the order transform applied to the graph of g of x to give? So how do I turn g of x into the -g5 minus 2x? I guess an alternative way before I go on to mine, if I tidy up that y equals, I could have y equals -g, -2 comes out the front, x plus 5 on 2, I reckon. Is that right? -2x. No, it must be a minus there in between. So that's a minus. So we have a reflection, a 5 on 2 units to the right, and that 2 there inside the function is dilated by a half, isn't it, from the y. All right, so you can pick it up from that, but what I decided to do, if we come down here, if we rewrite the two equations so that y equals g of x and then -y dashed equals g of 5 minus 2x dash, and then equate the two expressions. So y is equal to -y dash down here at the bottom of the screen, x is equal to 5 minus 2x dash. Rearrange, I get x dashed is equal to 5 minus x on 2, y dash is equal to -y. So my x dash y dash is equal to minus x on 2 plus 5 on 2 and -y. So what they are is, as a series of transformations, I've got a negative sign on the x, so it's reflecting about the y-axis, multiplying the x value by a half, so it's dilated by a half from the y, go 5 on 2 units to the right, and I've got the y value being multiplied by a negative, so that's reflecting about the x-axis. So I've got reflections about both axes, and then a half from y and 5 on 2 right, which turns out to be A, I believe. Reflection in the x, reflection in the y, dilate by a factor of half from the y, and 2.5 units to the right. All right, so there are a couple of ways you can approach those, just depending upon your preference. Okay, again, another matrix transformation. So x dash equals y dash equals. Rearranging it, x equals and y equals, and then substitute those values into the equation, y equals the square root of x. So I'm sort of hoping we get to that stage there and feeling relatively comfortable. Multiply the 2 across to here. So that's where that comes from. Multiply the 2 through. I get minus 2x plus 2, so I just wrote it as 2 minus 2x. Take the 1 across and I get 2 square root 2 minus 2x minus 1. And that's the same as E. 15 is probably similar to the question 12 or the one on the previous page. Again, I just try to write y equals in the same format as y equals x squared. So y on 2 is equal to x minus 3 all squared, and then we can compare the y values and the x values. So y is equal to y dashed on 2, x is equal to x dash minus 3. So bring the 2 across, y dash is equal to 2, y x dash is equal to x plus 3. So x plus 3 means 3 units to the right. If y dash is equal to 2y, the y value gets multiplied by 2, so it's a dilation by 2 from the x. And D corresponds to those two transformations. Which matrix determines a dilation from the x-axis by a factor of 4, followed by a dilation a factor of 6 from the y. The mistake we make here is thinking, well, 4 is the x and 6 is the y. But if I'm going to dilate by a factor from 4 from the x-axis, the y value gets affected, so it's 4y. 6 from the y-axis, x value, so it's a 6x. So I get 6004, which is D. Into the home straight. Again, we've done a few of these already now. Y is equal to the square root of x. So x, actually a little bit different, isn't it? Because we've got it sort of a double transformation here. So I thought the easiest way was just to multiply out that 2 by 2's matrix. So don't forget, -1, 0 times 2, 0 gives me -2. -1, 0 times 0, 1 gives me 0. 0, -1 times 2, 0 gives me 0. And then finally, 0, 1 times 0, 1. So 0 times 0 plus 1 times 1 gives me the 1. So that 2 by 2 matrix multiplied give me -2, 0, 0, 1. So x dash is equal to -2x, y dash is equal to y. So we're going to reflect it. The x coordinate gets impacted. So we're reflecting about the y axis, and we're also dilating by a factor of 2, which is B. And finally, again, we have another transformation matrix. X dash is equal to 3x minus 1, y dash is equal to 2y plus 4. Rearrange to get y equals and x equals. So x is equal to x dash plus 1 on 3. Y is equal to y dash minus 4 on 2. Substitute those into the equations that we're interested in. So that's we are there. And then we want to get it into the same format as our question. So if I multiply the 2 across, I get 2 times x dash plus 1 on 3 all cubed, and then bring the 4 over. So there's my answer. And so then I want to correspond or match the A, B, C, D values off, and I get 2, 1, 3, 4, which is A. Good work.